Hi, this next project is going to be a Zeta 2 single board computer. If you've watched my RC 2014 videos, then you're probably already familiar with the Z80 and some of the retro computing projects that I've worked on. This is this is a different kit. This one here was designed by Sergey Malinov, and it's kind of an offshoot of the N8VEM single board computer project, and it's called the Zeta 2. You can order the boards online. The large boards cost, I think, $20 each. There's a smaller board here that I believe was around $6. So what we have here is this one would be the Zeta 2 board itself. It's going to have, in one of these 40-pin sockets, it's going to be your Z80. It's going to have a parallel port. It's going to have RAM, ROM, floppy controller. It's all going to be on there. Everything we need to implement a computer on one board. No back plane or anything to plug it into. Battery, real-time clock. And the second board is called the Paraport Prop. It uses a parallax propeller to implement a VGA and PS2 keyboard terminal that you can use to interact directly with the Zeta 2. It's a big layout for the propeller there. There's also a spot to mount an SD card. Over here we have serial VGA PS2 keyboard, and it'll end up mounting directly under it via this parallel port header. So of course this one's entirely optional. You can talk to the Zeta 2 itself through just serial. And then this third board, the smaller board here, I believe is an SD card socket. Yeah, it's the PPISD. It would let you hook up, without the Paraport Prop, just the Zeta 2 and SD card socket piggybacked on this parallel port that would let you have storage using an SD card. So I'm going to start by building out the Zeta 2. Hi, I have finished soldering up the Zeta 2 single board computer. Here it is. All of the IC sockets are mounted. I haven't populated the ICs yet. Other components I've mounted are all of these capacitors. Lots of 1 UF capacitors, a 10 UF, a 47. Some resistor banks. One there, another one there. Socket here for a battery backup for the non-volatile memory. Serial port, floppy port, 3 crystals. Reset switch, power and halt LEDs. The parallel port jumper here, I used a Raspberry Pi stacking header with the thought that I can take the Paraport Prop board, mount it from beneath like so, and still have access to the top there. I think that's about all there is. See, I colored the power jack red. This thing does run on 5 volt, not 12 volt, so I figured I'd make it a special color. Then I would hopefully remember that and not plug the wrong transformer into it sometime and ruin it. Well, that's it. Now it's time to start populating the chips for it. Here's the Zeta 2 now fully assembled and populated with all the chips. Here we have the serial port, floppy port, parallel port. So going through some of the more important chips, here we have the floppy controller, here we have the 16550 UART, the Z80 counter timer chip, 8255 parallel interface chip, the Z80 CPU. One of these is the flash ROM, and the other is the RAM chip. Over here is the reset button. There's 2 LEDs. Here's one power LED and a halt LED. Down here we've got 3 crystals, 8 megahertz, 1.8 megahertz, 16 megahertz. Serial driver chip here, Max 202. Bunch of just random 74 HCT logic scattered about. There's a Dallas clock and a Dallas NVRAM controller chip. And there's a battery here. I haven't actually enabled the battery. There's currently a piece of tape over the other side. A little crystal for the real-time clock. Flipping it over, you can see the header that I put in there for hooking up to the Paraport prop board when that's done. Okay, here I have the Zeta 2 hooked up and ready to go. On this side I have a USB to serial adapter. It's hooked up through a gender changer to a null modem adapter to another gender changer, and then finally into the serial port on the Zeta 2. Kind of a conglomeration of stuff from the box of computer parts and adapters. Here I have the power hooked up to a USB connector that will supply a barrel jack giving 5 volt to the board. All we need to do, plug this into my hub and it should turn on and we should be able to see it on the serial port. I will switch views to the computer. We will give that a shot. Okay, I'm about to plug in the Zeta 2 board. Just plug it into the USB hub so it gets some power. Nothing happening yet. Let me push the... Oh, there it is. Appears to have reset itself, so it's in some kind of a bootloader. 512K of ROM, 512K of RAM. It's good. Let's tell it to load CPM. So it booted off of CPM. Now I know that this thing has, from what I've read about it, it has both a RAM disk, a ROM disk, and the 2 floppies. I haven't plugged the floppy drive in yet, but it should have booted to the ROM disk, so that should be our B drive. Yeah, so we've got lots of CPM files on the B drive. Let's look at the A drive. The A drive should be the RAM disk. Not surprisingly, the A drive is empty. Let's try running something on the B drive, mbasic. Okay, there's Microsoft Basic system. So that was very easy to get it up and running. You know, given that CPM is installed in the ROM like that, we didn't actually have to prep a floppy or anything. Let's see what this B drive looks like. It's got 6K left. What else do we have here? Let's try, what does survey do? Okay, drive A, 24K bytes. Yeah, so there's a bunch of space left on drive A because it's empty in its RAM drive. Drive B, 378K, 59 files, 6K remaining. Yeah, that looks like our ROM. Tells us something about the memory map. Tells us some I/O ports. Looks like it has an X modem, so if I could XM, receive a file from you, then let's put it on a:/zork2.com. Transfer, send X modem. See if that works. It's uploading zork2.com. And let's also do an xmra:/zork2.dat. Transfer. Whoops, not receive. Transfer. Send X modem. zork2.dat. Be taking its time. Oh, there we go. It started transferring. Thanks for the upload. Let's go to drive A. Got Zork 2. Run it. Okay, there's Zork. It's running. Go south, 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 southwest, south, Oh yeah, eaten by a grue. That'll never happen. Southwest. Same, perfectly safe. Oh, you've died. Yeah, we kind of figured that would happen. It did tell us we'd be eaten by a grue. Okay, quit. So yeah. Stat 8. Whoops. B colon. So B is our RAM disk. Or cut. B is our ROM. Let's stat A colon. Yeah, we can see A has 278K. Let's see, that was what survey. Okay, yeah, so the RAM disk works, the ROM disk works. I was able to upload something, I was able to run Zork, and it comes with a lot of programs on it already. Okay, let's try hooking up a floppy drive and see what happens. I have the same floppy drive here that I used on the RC 2014. Plug that in there. And then I need some floppy power. Which I have down here. We'll grab a fresh disk. And then let's try booting it up again. See if we can get the floppy to work. Okay, let's try this. We have the floppy drive connected now. I'm going to power up the Zeta 2. Zeta 2 is started. Let's go into CPM. Like before, we've booted to the ROM. But we should now have a C drive. Yeah, so the floppy just made this little clicky noise. Have not formatted this floppy. It's probably still a Windows floppy. Let's see if we have a format utility thing. Let's try clear dir C colon. Overwrite the directory sectors of drive C. That sounds like what we want. Oh. Maybe it needed to be uppercase Y. Let's try uppercase Y. Directory cleared. Do a directory on C colon, no file. Let's try X modem, XM receive, C colon zork2.com. Send X modem, zork2.com. Starting X modem transfer. Do an XM RC colon zork2.dat. Send X modem zork2.dat. Okay, there, we're receiving a good long file this time. I could hear the floppy seeking. Looks like it's going to flush its buffers every 16K or so. Okay, let's stat drive C. So we've used up the 100 and some odd kilobytes. Let's do a directory on C. There's Zork 2. We'd expect. Let's run Zork 2. It's good and slow this time because it's coming off the floppy. South, 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 southwest. Whoops. Well, if I can misspell southwest, it still works. South, pitch black. Yeah, that's not good. Up, we died. Looks like Zork is working. Quick. So yeah, the floppy disk appears to work just fine. Let me try that survey command again. Let's try d:"survey. This should tell us about our drives. Yeah, so we've got drive A as our RAM disk with a bunch of free space. Drive B is our ROM. Not a whole lot of free space left on the ROM. Drive C is our floppy drive with about 1.3 megabytes free. This is the parallel port prop board. It's going to mount underneath the Zeta 2. I've already soldered the SD card socket. That's the only surface mount component on here. But the pins are visible enough that it was easy to just hand solder with a fine soldering iron tip. No surface mount skill needed there. Okay, here's the completed Paraport prop board. It has a BGA connector, PS2 connector, a serial connector. The propeller's the big chip there. Over here we have the SD card slot. There's a speaker. These two resistor packs, it called for 14-pin ones, but I had 16-pin ones, so just plugged them in with an extra pin overhanging the end. That's fine. It's a 3.3 volt regulator. Here's the EEPROM for the propeller. Serial driver max 202 is what I used. I think you can use either a 202 or a 232. And then this here, it called for 74LS06. I substituted a 74LS05. This big header here connects to the underside of the Zeta 2. And this little header just brings out the unused parallel port pins. We won't be using that because it'll be buried in between the two boards. Okay, it's time to try out the Paraport prop board. Let's see if we can make this thing work. I have it mounted to the bottom of the Zeta 2. I plugged in a VGA monitor, and I plugged in this Model M Unicomp keyboard clone. Let's add some power. Okay, the monitor is working. It's running in the Paraport prop terminal. We've got CPM we can boot into. It's got a couple new devices here. It's got disk 4 is PPP SD0. That's the SD card slot on the Paraport prop. And serial 1 is the terminal. I assume that's what we're talking on now. So if we hit C to continue. Yeah, look at that. We've got all of these additional drives. I haven't plugged in an SD card yet, so those won't work yet, but as usual, our B drive, the ROM is good. So we can see it seems to be working as expected. Let me see if I can find an SD card, and I'll try out the storage on the Paraport prop. Okay, this here says it's a 4 gigabyte SD card. We will plug that in. And can I erase one of the drives? There was a clear on drive E:. Sure. Not cleared. Okay. Clear dir E colon capital Y. Directory cleared. Now we can use the pip tool. We'll see if we can copy something. So let's pip E colon asm.com equals B colon asm.com. That should have copied a file to the SD card. So if we look at the E colon, it has a file on it. Let's run survey. Yeah, so drive E has 8 megabytes remaining. If I eject the SD card, what happens? Let's see. Bad sector, understandable. Let's plug the SD card back in. Okay, yeah, so the SD card storage on the Pairport prop seems to be working. Okay, so that's as much as I think as I'm going to demo on the Pairport prop board. It worked as expected. It used the propeller chip to give us a VGA console and a PS2 keyboard, and we're able to interact with our Zeta 2 through that. So this would be a great way to give yourself a fully self-contained retro computer that you can hook up to a monitor and keyboard. Okay, so I figured I should at least demonstrate this thing interface to something, you know, because it does have a parallel port, so we had to hook something to it and try to do something interesting. So I've got out one of my Nixie tube display boards. These are from my original calculator prototype that I designed. They're a relatively simple board with 3 shift registers, 4 drivers, and 4 Nixie tubes. We have that wired up. It takes 3 bits to control this, a data bit, a clock bit, and a latch bit, as well as a hot and ground. We've got all that hooked up to the parallel port on the Zeta 2. We also need about 138 volts DC, so we're going to use my high voltage power supply to do that. So let's plug the Zeta 2 in. Okay, so you can't really see this, but I've booted it to CPM. I'm running Microsoft Basic. Whoops. So we've turned on the Zeta 2. I'm going to turn on the high voltage power supply. It's just lit up some random stuff on the display. That's just whatever the shift registers have initialized them to. I already have a program loaded in Microsoft Basic that's going to do a simple count on the Nixie tubes, and it'll just count as fast as the basic program can count, which is not real fast. But let's run it. There we go. You can see it's just counting up from 0, and it'll sit here and do this forever. So that's a quick demo of the Zeta 2 powering some Nixie tube displays. And if I wanted to, I could probably turn this into yet another Nixie tube clock. Be relatively simple to do because this thing does have an onboard clock chip. I think at this point, since I've done so many videos on the RC 2014, that it's fair to compare the two in case someone is watching this deciding, you know, what kind of retro computer do you want to build. Over here we have the Zeta 2, over here we have the RC 2014. You can see the Zeta 2, almost everything is all in one board. You know, the Pairport prop down there is entirely optional, you don't need that. So in one board you've got yourself a floppy controller, serial, the counter timer chip is on there, there's a real-time clock. Does everything you need. It's flash programmable, and once you flashed it, CPM is installed on flash. You don't need a storage device to run CPM. You don't need to hook up a floppy or an SD card at all to it. It was just almost trivial for me to get this thing up and running CPM once I'd finished building it. On the other hand, we've got the RC 2014, which if you've watched my other videos, I've implemented a lot of cards for. I implemented a floppy controller, I implemented an SD card storage, I implemented a banked RAM and ROM to support the CPM, I've implemented different serial ports and counter timer chips and bus monitors. This RC 2014, it's a great platform if you want to be able to be making your own little modules and plug things in and remove them and configure it in different ways. Pretty well expandable. I mean, this is just a back plane down here. You can make, by mixing and matching modules, almost anything you want. So the disadvantage of this is, if you are into making your own modules or mixing and matching modules, then you're going to have to get familiar with how to program your own custom firmware and do stuff like that to implement your own configuration. Whereas the Zeta 2, just the stock configuration was enough to get me going and run CPM. But it doesn't feel to me like it offers quite as much room for expansion. You do have this parallel port here, and it's got 24 I/O lines, so you could do 24 bits of I/O. We could implement almost any of the projects that I've done with that I/O. We could, hook up a speech synthesizer or Nixie tubes or vacuum fluorescent displays or LCDs. There's 24 bits of I/O is good enough for that. So I think it just really comes down to, which platform you like better. And there are other platforms out there. For example, if you look at the N8 VEM, you'll notice that it is a backplane approach, and there's a whole variety of N8 VEM boards that you could do. I might try building one of those kits at some point. It'd be kind of fun to do that. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.